Hello everybody, and welcome to part B of exercise 4. We are still looking at page 73 in the workbook. Here's another example of trying to make a Cayley table for a factor group. Okay, so in this particular example, they're starting us off with the group A4 and a subgroup of A4 that has 4 elements in it. Okay, now this is some notation that we haven't seen for a while. What is this group A4? What does that represent? You might remember that we use the word alternating group for that. And in words, A4 just represents the set of all even permutations of a set of 4 elements. Okay, how many permutations are we talking about there? Okay, well, remember that way back in chapter 5, when you talked about symmetry groups, we talked about the fact that the symmetric group on 4 elements, that would be the set of all permutations, has 4 factorial things in it. That's 24 elements. And the number of even permutations is going to be exactly half of that. So the number of elements in this group G that we're talking about is 12. That's quite a few elements. So I'd like to avoid having to write out all of those elements if I can avoid it. And it turns out we can avoid that if we kind of think about this the right way. Okay, so we know that A4 has 12 elements in it, and our subgroup, looking at it, has 4 elements in it. So how many different cosets should we have of H and G? Okay, so there are 12 elements in our group and 4 elements in our subgroup. That means that we should only have 12 divided by 4 equals 3 cosets that we're talking about. So the fact that that number of cosets is relatively small is going to allow us to kind of get through this problem without having to really be aware of everything that's in A4. Okay, so with all of that in mind, let's see if we can get started on this process. We just mentioned that we're expecting exactly 3 cosets, and one of the cosets is staring us right in the face here, the identity coset. Okay, so one of the 3 is already calculated for us. We don't need to calculate that ourselves. Okay, so the question then is, what are the other 2 cosets? Well, we need to take an element that's in A4 that's not in this first coset, okay, that we just talked about, and think about the coset generated by that element. And I'm going to start with the element 1, 2, 3. How do we know that that element is in A4? Well, here we have to think back a little bit to stuff that we did in chapter 5. Okay, so I want to clear myself a little bit of space here. I'm making the claim that the cycle 1, 2, 3 is an even permutation. That's true because of the fact that we can decompose that into an even number of 2 cycles. We can write it as 1, 3 times 1, 2. You might remember doing this back in chapter 5. Okay, so the fact that that's an even number, it's a product of 2 cycles, tells us that that's an even permutation and therefore something that lives in A4. And now the question is, what coset would we generate if we took 1, 2, 3 and multiplied it by each of these 4 elements one at a time? There we'd have to do some calculating. Okay, so 1, 2, 3 times the identity is just going to give us 1, 2, 3. And the other 3 elements, I'm going to leave it to you to confirm my calculations. So 1, 2, 3 times 1, 2, 3, 4, if you do the arithmetic there, is going to give you 1, 3, 4. That's my claim. And if you keep calculating, here's what you're going to get. 2, 4, 3, and then finally 1, 4, 2. All right, so here's our second coset. And to get our third and final coset, we need to choose an even permutation. Oops, hang on a second, let me rewrite that. That's not on the list of things that are already in cosets. So these 4 elements are already used. These 4 elements are already used. Can we think of another even permutation, okay, that isn't one of those 8 elements? Well, we could just take 1, 3, 2. That's an even permutation for the same reason, because we can decompose it into an even number of 2 cycles like this. Okay, and if you take 1, 3, 2 and multiply it by the 4 elements up here in H, here's what you're going to get. Again, I'm kind of leaving it to you to confirm these calculations. 1, 3, 2, 2, 3, 4, 1, 2, 4. Okay, and then finally 1, 4, 3. Okay, there's our third and final coset. All right, so we're ready then to make a Cayley table. Okay, remember we're making a Cayley table for the group G mod H. That's the set of the 3 cosets that we just found. So let's go ahead and list those across the top. We've got H, we've got 1, 2, 3 times H, and we've got 1, 3, 2 times H. Okay, and then we've got the same cosets going down the side here. Okay, and our operation is composition here. All right, and the fact that there are only 3 cosets here make the calculations not too bad here. So if we start with the identity, H, we know that we multiply that by any other coset, we're going to get the same thing back again. So the first row and the first column are not going to be so bad. We've seen that behavior before. All right, and then what about this coset times this one? 1, 2, 3 times itself. Well, to do that calculation, we need to take 1, 2, 3 and multiply it by 1, 2, 3. And I'm going to ask you to confirm the fact that when you do that, what you get is the permutation 1, 3, 2. Okay, and then moving on to the next one here, we're going to take 1, 2, 3 times 1, 3, 2. That gives us the identity. So that's going to get us back to just H. Okay, we just keep doing this. Right, so next up would be 1, 3, 2 times 1, 2, 3. Again, that's the identity permutation, so we're going to get our identity coset. Okay, and because we know that this is a group, we kind of already know what the last entry has to be here. It's got to be 1, 2, 3. Okay, since that has to appear in every row and column of our table. All right, so we are done. And what we just calculated here is, just to put it into words, that's the Cayley table for the factor group A4 mod H.